Look out.
Good way to start.
Thank you. Class may begin.
Class
Class has started.
has started.
Roll Tri-Delts.
Forward.
Okay, so
Building cubes.
10, 25, 25, 30, 10. 40.
Hello, I turned it off. Oh, sorry.
So I will return back to the grading schedule if it is missed, but let's do the first one. So
10, 25, 25,
roll
30,
functions.
10, 20.
So it's quite simple. Think some of you may have done it with help of electronic friends, but the best if you did it by pen and paper, right? So the way to draw a polynomial is so you can plot each of the factors separately. So this Gaussian shape separately, then you can put how do you call it in middle school? Factorize?
Find the zeros.
Yeah, find zeros.
Those are factors.
And then in zeros, function changes sign, right? And then you do plus, minus, plus, minus, plus, minus, and you draw the function. So looks at zero sign 0 and plus minus square root of 3/2. Be generous if it is completely off, if the number of humps is different, then we'll draw a point or something like that.
Sam, confused.
Huh?
Dark, great.
Hey, Sam, the whole thing. The whole thing.
Oh, yeah, the whole thing. Be generous to me.
How
many points?
Find
Yeah.
expression. So this expression is has several names. Some sources call it Rodriguez formula, some of them call it generating function. The meaning, the eigenstate of oscillator that you already know, you have a Gaussian exponential multiplied by polynomials of different order. And this formula is one of the ways to generate this polynomials. So if you take derivative of nth order and then multiply by exponential of the opposite sign, the exponentials disappear and you can get zeroth order should be 1, first order should be minus x, second order minus 1 plus x squared, and the third one 3x minus x third, corresponding to your task number 1, right?
Yes.
So if you see the confirmed skill of taking derivative, just give.
Confirmed skill.
Also, do you remember
What's Samuel?
do you remember how to do derivatives?
Yeah.
You-
I think I did the going
And-
through, like, make your.
And I encourage you to be generous to each other in points, but if you want to leave critical comments, go ahead.
Okay.
I'm leaving supportive comments.
Supportive comments are even better.
I wrote confirmed skill.
Confirmed, okay. Okay. So,
Where's your axis?
Up and down.
Hey, yeah.
B number 3, also points. Do you see any connection with the class material?
Yeah, it is class material.
Which concepts from the class are illustrated here? I don't know how to dance and express it.
See, I don't know. I feel it's related to wave function of harmonic oscillator, the unnormalized one. Unnormalized.
Contingent reason.
Christmas time to shine. No. No, we. Meeting is done.
So, we do have function one as, and we skip normalization, as Patricia was correct. Eigenstates of harmonic oscillator, leaving away normalization, so X times exponential. And when we apply this combination of linear function and derivative, what do we get? What does happen to the function?
If you do the.
So when, like, I have no doubts that you completed this, but when you apply this combination of X and derivative to the function one, what do you get as a result?
Well, that, like what you have to.
Please tell me by words.
Well,
Task of this class is convert equations into words and words into
you
equations.
would take your phi, like X is equal to phi, and then your partial derivative in terms of X is just gonna be when you partially derive phi. So it's gonna be the basic equation minus the partial derivative.
You're absolutely correct, but you're too technical. I want something a little more overarching bird's eye.
You take the function minus the derivative.
Mhm.
It's derived.
If phi one is related to the state number one of harmonic oscillator, you see,
Yes.
it's camel is how many humps?
One hump.
Two. Ground state is one hump, state number one is two. And now you apply this differential operator, which is simplified. And what do you get? How do you interpret this function? How many humps would it have?
One, because they have X squared.
How many humps?
Is not correct. 3 humps, 4 humps.
I've heard one, I've heard two, and I've heard four. And one number in sequence was missed. Yes.
So it has one more hump
Yes.
than.
And if you want to draw it, it will be inverted parabola that crosses zero in 2 points. And when you multiply it by exponential, it will go this down, up, down.
Oh, sure.
Okay? So we get what?
Three
The
humps.
second.
The second state of the harmonic oscillator. So this is a simplified, like, educational analog of which operator? I probably try to dance it.
Oh, boy.
Well, it's on wheels.
Yeah.
Oh, the stepwise
Stepwise.
of
Of a harmonic oscillator?
Which operators increase quantum state by one? There is a Darwin theory of evolution and
Evolution operator.
There is a Darwin theory of evolution, and opposite people who do not believe in evolution tells.
Annihilation.
Oh, the creationism, yeah, creation of.
Okay,
Of course, it creates another one.
or weather operator because stepping up. Okay. If I would be a little younger, I would jump on a table. I would just don't want to risk.
Okay.
I wouldn't want you to risk it. either.
No, me neither.
Okay, so if we apply this, if you change the sign here from minus to plus, and we apply it to the same state number one, what do we get? What happens to the polynomial? How many humps do we have?
Oh, I didn't even see the second.
Huh?
2.
So take by one, which is like x times e, which has 2 humps.
Oh, the answer?
Added.
Yes, for the answer,
1 hump.
one hump,
Yeah, because there's
which I can
no
state, which I can state is
ground state.
ground state. So you converted first state into ground state. That means that this is operator of.
It's annihilation.
Yes. So,
You spelled it.
subconsciously you learn creation and initialization operator, even do not recognizing their names. Okay?
There's an H.
And I think everyone did this derivatives correctly. Just credit each other. And write encouraging comments.
My brain's so much. Samuel? I know I did that one right, because I did. And
Good
it's
try.
right.
Okay,
Success.
X.
so do you remember?
Oh, well. Oh, well.
That's why Rick shut up about my heart.
What was asked in this question for?
About yourself.
Let me track back because I don't remember how the question was.
Oh, your question
Analyze.
was fine.
Does it correspond to any observable, right?
Yeah.
Okay.
Yes.
So, and the multiple,
Question is 30 points.
uh,
Mega points.
yes, it's mathematically simple, but it is philosophically important. So,
Simply got that wrong.
so you open brackets and there is only one mathematical error that one can do. The mathematical error that one can do is to.
I guarantee you there's more than one.
Come on, no, it's just opening brackets. So the error is that x times x, derivatives times derivative, but then we do have x derivative times x and x times derivative. So there is a big temptation to just combine it together, but and looks like number 2 in front.
I did.
But no, in quantum theory, you cannot do it. So the derivative over x and x times derivative are different things, right? So withdraw little points if you do not see, just generally withdraw like 1 or 2 points. Do you see?
What are you talking? So
It's with the x in front of the derivative versus the x behind the derivative. So.
I just don't know what he was pointing, like what ones he was pointing at
Yeah.
on the board. So it's the partial derivative of x times x versus x times.
You are repeating words of Patricia. I'm not understanding what he's doing.
No, I just missed what you pointed at. I wasn't looking when you pointed.
Exactly, sure, Stephen. I don't understand you. I don't understand what you are saying. First time we met, she told like, I was telling to all graduate students, so, I don't understand you. Can you take a microphone? I took microphone. I still don't understand you. So I'm pointing on to this.
How is it not the same thing? Like, how is it not? I really don't know how to apply for it.
Well, if everything is perfect, do not withdraw if something if there are little changes.
Sorry.
Yeah.
I still do not understand the concepts that does not strike this to house. Like, sorry, like this. Like,
Oh, why the points?
yeah,
You cancel them.
yeah, I was wondering.
Because the x is in front of the derivative in the first one and behind in the other, so it's not the same.
Yeah, I was wondering, like, okay, if you multiply this like this. Get this like this, how do I know it's in front and all?
So we are allowed just algebraically open the bracket and then we need to start thinking. So I can write more, but maybe let's book on this little box. And give me a little hints if you see that this step, you see an error in this step in what you are writing. You can do it secretly so that others do not see. Give a sign if you see this error.
I don't see the error,
Yeah.
but
Okay, at least one, maybe more.
I think the train was departing in the wrong direction on this one.
Yeah.
Okay, so the train. See, here it is ddx x ddx. So when we say, I do not have figure of speech yet. X ddx x.
Whoa.
When we write down an operator, right? Exponential operator, we should always imply that after operator there is an unknown function. So it's not just a symbol, it is something that acts on a function. And same if we have a matrix operator, we should always think that this matrix acts on a vector. And if you have this combination, right? If we open this little thing, We were doing it in class, but let's do it once again. So
Right.
first term,
So neat.
d
How dare you?
dx to x times phi equals d dx of x times phi unchanged plus x d dx of phi, right? So it was this term. And second term is minus, it's only x d dx of phi. So if you take this one and subtract x d dx of phi, we see that this term and this term are identical, sorry, they're cancelled, and then the result will be dx over x will be 1, right? 1 times phi. And if you remove phi, which we keep on, we imply, then the result will be 1. So it is not 0, it is 1. And the name for this operation is when we swap the order of operators. Yes, m plus 1.
Drag it up.
We should take a tally at the end of this semester.
But does it make sense better?
Yeah, it does.
Okay, and then we have this x squared, derivative squared, and then this commutator, which inherits maybe imaginary unit and 1. So now let's analyze what is x squared.
Potential energy.
Yes,
What's the potential energy?
for harmonic oscillator.
Okay. Okay.
We focus on harmonic oscillator only. Now, second derivative is kinetic energy, and this constant.
Dimitri, I have a question. It doesn't, most of the kinetic energy I've always seen is derivative to dt squared. But this one is dx squared.
Over what?
Like it's d squared dt squared. Second derivative, this
Over what? Over which variable?
time.
No. No. I am so happy you asked this question now. This is a critical thing. You can keep sitting. I understood your confusion. We have time to complete. So let's briefly discuss it. So the momentum. What is the difference between classical momentum and quantum momentum? We discussed it, and
Operator?
yes. So classical momentum is what?
D over dx.
The position over time.
Yes.
Position over time, derivative over time, right? Yes.
Yes.
Stephen was telling the whole story before. You can rest if you want. I was criticizing you for this confused last Wednesday. So classical train of thought with momentum velocities, position over time, right? And quantum momentum is
Position over.
no position. There is no.
Position of
You need to imply wave function, and you
like distance and location.
derivative over space. So if you apply this operator of derivative over space towards wave function, this operation corresponds to quantum momentum.
Okay.
Let's vote. Who agrees with this? Oh, probably. Who disagrees with this statement? Oh, yes. Who considers it's confusing and doubtful?
I admit it's confusing.
Huh?
I admit it's confusing.
It is? Okay. But you remember it in the middle of the night, right?
Yeah.
So if you take derivative, apply this derivative to a plane wave, you will get momentum. And other functions are a little more strange, but generally, if you plug exponential e to the IPX, applying derivative will extract P. Right? So this is quantum momentum, and kinetic energy is momentum squared. If you take first derivative squared, you will have the second derivative. So if you see second derivative, you can tell it is similar to kinetic energy. Okay, and I think these two statements should be like about 10 points each. If you identify that it is similar to kinetic and potential, just create generally. Why this product of creation and equation is not equally equals to kinetic plus potential? Because it is a quantum system and because there is a 0 point energy in each quantum system. But be generous. If you just see something, if you see declaration that this term exists, just keep on.
Didn't even give me anything.
I forgot, but
Okay,
I didn't put that to it.
so done, right? Yes.
Done.
Number 5. So let's compete. How many examples do you see? Who has 5 examples in the thing that you are grading?
5.
Oh, you can just open and show it in fingers. 5, 3, 6. Oh, 2. Patricia? 5. Okay.
The average is 5.
The one with 6 should give those two missing. So let's look.
Should be a 1 point curve.
I think let's do 2 points per example.
That's fine.
Twelve
Okay,
out of 10, Ava.
so vibrations in molecules. Does everyone have it? No? Vibrations?
I don't think I put that.
Not yours.
Someone existing vibration?
Or, the one you're correct.
I was just kind of
Okay.
thinking of
Yeah,
stuff.
that's what I was doing. I was just like, I'll just give 2. It's like,
Okay, so some of you do not have vibrations. Okay.
Wow.
Libration in polar solar. No?
Bowl and springs.
Ball springs.
yes.
Everyone?
Yeah,
Okay. Plus. Plasmons in gold nanoparticles. No one?
I think all of our examples were much simpler than yours.
Like, I was swing, a swing.
Yeah, I said, I think I did the pendulum on the grandfather clock and it's.
Radio frequency.
I think I have radio waves on there.
does.
I have radio waves on there.
Okay. Yeah. Electric field and laser.
No.
No?
Lasers. That's a
Okay,
good one.
I don't know.
so what else? What I didn't mention and you guys have?
Waves.
Okay,
Seismic waves, I guess.
Bungee jumping,
huh?
bungee jumping.
Fair.
It's
Yeah,
like, you jump off a bridge, but you're attached to a line. and you down.
Oh, okay, okay.
yeah.
I like this example. What else did I miss?
Hearing,
Hearing, acoustic waves, situations, hammer tone, zing. Okay. Hammer tone.
Camera tone.
Hammer tone. Let me check Google Translator. You have a 2 poles.
That's it's what they use to check your hearing. It's like-
oh, tuning fork.
Tuning fork.
Oh, okay.
It's
Sound waves.
I thought it was borrowed from. It's not in my native language, and I thought it is international.
I mean, maybe we just don't know.
Tuning fork.
That's,
It's very visual.
it's the little
Yeah.
like,
Okay,
yeah, the little metal thing you bang it in.
okay. I really appreciate this class. I learned something each day. So that is number 5. Why do I have these little things in here?
Extra credit.
And what was the extra credit? Let's check. Normalize second excited state wave function, we find factor n2. Okay. So, did you have any attempts to do this extra credit?
I did not.
Yeah.
I tried it.
Okay.
I didn't do it very well, but
Okay, so wave function squared. absolute value squared should be equal to 1. And then when one performs wave function squared of this second polynomial, which I think we can find in the problem number 1. So x times x plus x cubed. If one takes it square, it converts into 3 terms. A term of the zeroth order, term of the no, 4, first, second, and fourth. And as soon as one recognizes this integrals, one can take them, add them together, and so just adding square root of pi with different factors, and then 3 minus 2 plus 1 will be 2. And this factor 2, right, is something that differs result of acting creation operator on the first state from normalized second state. And this square root of 2 that has been found in here. In here. Is something that set up a path for us to design and use creation and annihilation operators. But mathematically, it's just taking this, well, if you take only this portion squared, then there will be x to the 4th power, x to the 0th power, and x to the 2nd power, right? And if we neglect this coefficients alpha or took them out of brackets, it will be 3 integrals, e to the power Gaussian times 1st, 2nd, and 4th order. And those can be either taken or found online because of those table integrals. Yeah. If I would do it in the class, it would take the whole lecture. I think we are done. So please add,
Yeah.
please add together.
And I'll even circle it for you.
Yeah. So please add together all numbers and write them on the top page. Then there is a chance that I will not even open the rest of the pages.
Yeah.
And divide them by 100 to see that a lot of you can have more than 100%. Oh, I want
Two, 25.
oh, you want to?
Brent just wants to see the train I drew.
Oh,
Departing in the wrong direction.
There you go.
Yeah.
Points on the corner.
Number 4 was,
30.
yeah.
I tried so hard that everyone gets over 100, and you guys
Strict standards simply did not.
below 100. 99. Good grade. It is what I.
Couldn't just round.
No, I originally had it at 100, but I was like, I just want to be difficult.
Thank you so much. Let me watch if you have fun picturing.
I drew a train.
Oh. I find a caterpillar. I found like a closed, yes, closed. Someone wrote it to Eva.
You're always a dinosaur.
Okay, maybe baby dinosaur that is hard to distinguish.
Yeah, I think it's good too. I like both of
It's
these.
close enough to a caterpillar. That works.
Oh, yes, train, right direction.
Yeah, it's departing in the wrong direction, but you know,
Good,
try.
good job, King.
I think I did not grade the extra credits for Melanie.
Huh?
Extra credits.
You didn't or you did?
I did not.
Oh, then I
Oh, it's okay.
will edit and then she will be the absolute champion.
I didn't finish it.
Okay, maybe next year I shouldn't disclose the projects until very last moment, that everyone will be so dedicated and trying to get maximum. It's knowledge about the project probably acts a little relaxing.
I'll retry it.
Thank you, thank you. You tried hard and I see the learning curve goes like a rocket.
Mhm.
So here are your favorite subjects. I cannot believe it is in 2 days. On Friday, you'll come
I
and
can't
present.
believe either, bro.
Even us.
And these should still be like 5 minutes long.
Yes, 5 minutes, no longer. The shorter the talk, the smaller chance for errors.
True, the more you ramble.
If you
the
don't
more
say
make
anything,
sense.
you can't make a mistake.
Who
But at the
is,
same time, if you keep talking, people can't ask you questions.
you know who is gonna like be watching?
Don't send out, please don't invite anyone.
I will invite everyone. to the whole program, but I will be fair.
No.
I will send it maybe an hour before the meeting, so most people will be busy. And
How about you do it 5 minutes
Yeah,
before the
yeah.
meeting?
I'll bring, well, probably David and Dr. Han will come or join by Zoom. But
It's okay.
it's more important to have big audience on the final exam.
Yeah.
And probably your research advisors will be very interested.
I do.
To take more, to take more.
I want Kent to come.
I will not. come.
Yeah, I don't want Kent to come.
That's so scary.
Yeah, I don't really want.
That's grad students can come.
Roger's 100%.
Wyatt will ask us
knows
questions.
I am.
I
so-
That's a brother one.
them to have like. no
Evan would ask us
knowledge of
questions.
How bad I am.
Just,
Okay, guys.
No, not yet. Let's.
We're not-
We're not done yet. Not done. Let's
Yeah,
go over.
minutes left.
Yeah,
How's maybe get.
Class is still going.
yeah, still going. Your screen is sharing, recording is going on, whatever. Class is going. Question?
Yes, based on the presentation, can we ask questions?
Yes, questions to each other are strongly encouraged. I'm still missing the way how to credit for questions, but questions will be recorded and credited.
No.
No?
Yes.
But you guys didn't present how to, how you can ask each other, or you want to ask me?
No, yes, ask you based on.
But our lab section will be completely devoted to preparing your presentation.
Okay.
So that's a good spot.
If-
like today,
Oh, yes. And I think it's most important, everyone is more or less ready. If the main client of today will be Elsa.
Client, you're the main client. Yeah.
It will be
Right,
fun
we
for
got, like, He kept like making notes in the code last week. I'm like, this is for Elsa.
It is on.
No, it's on.
It's dead or
But
something. It won't
yeah,
turn
the
back
light
on.
won't turn on.
It's not turning back on. I think it died right away.
It needs more batteries.
Batteries need to be replaced. Oh, there's batteries right there.
Yeah, one of the, in my 9 AM, the laser.
Bro, that's
battery
not their
died.
Oh my God, they're rechargeable freaking batteries. You can put.
Oh, by the way, Fred, visualize real and imaginary parts of the wave.
Yeah,
I think they're here, right?
okay.
You need to generate this figure and explain what it is.
So that isn't, how does that differ from the wave packet code? That lab that we're working on?
Sorry, Fred, repeat that question, please.
You're working
The
on,
ceiling mic can hear it.
you're working on a single code that we work on.
Yes,
But we need to understand what it generates, and we need to analyze the data. Sometimes analyzing the data is not only to just staring on the panels that it generated, but looking on the variables and creating new commands to analyze process and with new figures.
yeah.
So if you type plot real psi, you'll get red line. If you type plot imaginary psi, you'll get the green shot. You can plot them on the same.
Okay, all right. I might ask for.
It just explains,
clarification later.
because if you do absolute value squared of them, say, you will have just boring Gaussian function. You want to see the structure.
Yeah.
And this real animation will carry information about momentum. This bridges. Here's where I like this.
You have a grand old time you're going.
Yeah.
It's maybe some strength for the word. Interest.
On the wind.
So and this one is due
No.
Monday, but you just listen to each other and you be more than enough. Continue measures. There's next Wednesday measure homework.
This one.
Can that Wednesday homework be due on Friday instead?
Oh, I think
Oh my goodness.
Something.
Friday, Wednesday and Friday.
Yeah, Monday, Wednesday and Friday.
maybe instead of next Friday, let's do next Monday because
Give us a Friday on.
yes,
Okay.
exactly. So this
Wait, we
homework,
don't,
not off, but off.
We don't have class next Friday.
Really?
yeah, we don't have school next Friday. For what? For
Veterans
Veterans Day.
What's not?
Next Friday,
Okay, then
so.
subconsciously I didn't schedule anything for next Friday. So this due next Wednesday is just playing with matrices, right? So this homework were continuous functions and differential operators for harmonic oscillator. Next one will be matrix operators for harmonic oscillator. So you all will be masters of harmonic oscillator by the end of the
Heck yeah.
thing. This is what you all remember in the middle of the night, maybe. Single count, right? With its parameter. So. Well, there, come in. Come in.
FBI, open it up.
Now you can see that I will open myself.
This one?
Yeah.
Looks very different on my screen.
So the next homework, which is due November 14th, Monday. So let me, in the remaining minute, explain what it is. So the next homework on whatever, next.
We have next.
The next.
Yes.
We have homework,
That's
we have
literally like
our pre-
4 assignments.
yeah,
from now.
presentation on Friday, homework on Monday and Wednesday, no school on Friday, the following Monday, this is due. So yes, it is.
I didn't wear warning.
Email.
Last 30% of time, 70% of material, 70% of effort. You just writing. So. Back to the science, not just boring equations that are designed to torture young minds, but a little grain of true science.
A little?
Well, unfortunately, when you will be doing projects, it will be like a big chunk of science. So, which question did you even? Which question?
Couscous, do you know what that is?
Yes,
Like a tiny couscous grain.
it's a favorite food of graduate students and postdocs because you just have it stir
Yeah.
with water and if there is no time to go to.
No.
Oh, yes.
It's 11:48.
Yeah, it's more than enough time. So which question did we answer? Which scientific question did we ask to ourselves when we were studying our first model, electron in a free space? We were asking two questions: whether it is correct that the center goes on a straight line, right? And second question, what the width of the distribution is doing, right? Whether it stays the same, shrinks, or expands. Now let's ask the same style of question to Gaussian function in the harmonic
Oscillator.
oscillator. So what will be the trajectory of the center of this Gaussian? Whether to go on straight, whether to go with acceleration or deceleration, or maybe it will just oscillate like a sine or a cosine. But let's prove it, not mathematically, but with your MATLAB tool. Based on this code that you report on coming Friday, then when it will be next homework, you just run this code with the same settings as Elsa will do for her presentation and answer questions. What does center of the Gaussian wave packet does in the harmonic potential? And another question, what does width of this wave packet does when it moves there, whether it stays the same, whether it expands, whether it shrinks? Maybe, I just know the answer, maybe it will oscillate with the same frequency or different. So these two questions, and the all questions are formulated to assist exploring this little scientific question. So no derivations, enough. By that time it will be enough for derivations. Just run the code and verbally analyze what you see. What is our camera? Yes, everything is done.